Okay, here we go. Guys, what we're gonna do today is if you could start on 3H. Turn to 3H, please. Transposition of formula. I'm going to do the example 22 that is in your book.
What pages is it on?
Don't talk to me on pages. I am digital.
Okay. What digital page is it on?
3H in your textbook.
Okay.
Okay.
Page 142. Thank you.
Thanks very much.
You know some of those on the same.
Oh, look, a couple of won't go astray, I reckon.
Yeah.
Now, if you look at this, it says make f the subject. Sorry, f is equal to. I'm going to type it out here. F is equal to 9/5 c, open bracket 9/5 c plus 32. Now, this is the formula to convert Fahrenheit to Celsius and vice versa. Yes. Now, it turns out that you want to go from Fahrenheit to Celsius, so you want to make C on the left. Does that make sense?
Yes.
Okay.
Which one is this?
This is 3H.
A?
H.
H. Okay. At 1.
Now,
1H.
if you look at your book, there's a long way they go about doing it. So here is the quicker way. Ready? And I want to make C the subject of the formula. Okay? That's it.
That's so easy, sir.
That's so easy. So for example, here's another one. You know that speed equals distance over time, yes?
No. Well, no, I do.
Speed equals distance over time, and you want to make time the subject of the formula in terms of velocity or speed, if you like, and distance. So, same thing, comma, t, there. Now, let's think of another common formula, E equals mc squared. Now, you want to make mass the subject of the formula.
There's no Einstein in here.
No, well, one step at a time. So E equals to mc squared. You want to make m the subject of the formula, mass instead of energy. So you put solve, bracket, comma, m. Oh, that didn't work, did it?
Sir, couldn't
I don't think
you
it works. It's good squared.
divide
No, it works.
by
Is your comment too early or something? What a number.
That's a good question.
No, it's your comment.
I think it might be my comma. Now you're scared of the sack. I think in this case the m is protected. That is, it's
I know. In multiplied by 6.
Yeah.
yes.
Yes.
Oh, that's what was different about the.
Yep, you're right, Mr. Grigg. For all your technical needs, see Mr. Grigg. Okay. Now, is that okay?
Yes.
Now, if you go and look at the exercises from 3H, there'll be similar things, but none of them are going to be any more difficult than what I've just shown you. Okay, that's the first point. The second thing to show you is how to do simultaneous linear equations. So, if you could go in your books to that chapter, which from memory is 3I. Finding the point of intersection between two linear graphs. Again, I'm going to use the example in your textbook.
Actually, we did this yesterday.
Okay, very good. And I'll just show it to you live again. It'll be recorded. And it's y equals to 2x plus 6 and y equals to minus 2x plus 3. Okay. Now, there are two ways to do it. I'm going to show you both those ways. The first one is 3I. The first...
I like my way. They like Dan.
They like that.
No, I prefer your way. Yeah, I really just like putting
Menu 371.
Menu 371.
Menu 371. So I've written that on the board. You want to write that in your notes. Sorry. And yeah, in your notebooks. Menu 371. Now we are using X and Y, so I'll keep them. Now if the question says A and B or speed and time, S and T, you just change the variables accordingly.
You can still use X and Y.
You can still use X and Y, yes. So in this case, y equals to 2x plus 6. And I'm going to reverse the order. Minus 2x plus 3 equals y, just to show you that it doesn't matter how you put it in. Okay? It just pops out with the answer, and there it is. Simples. It's almost like that ad. Now, here is the second way to do it. The second way to do it is to go into graphs and put in the equation. Now, the sort of shortcoming of this method is that you have to put y equals to something. And y here is represented by the first function of x. Okay, so instead of y, you put in f1x. And in this case, again, I'm going to put 2x plus 6. There's your graph.
So if you had to rearrange the equation, sorry for interrupting, to make y the subject,
Yeah.
you just use the cas function you showed us.
Yeah,
before.
correct. That's right. Yeah, Daniel's right. If you wanted to make it in terms of y and you wanted to use the graphical method, you use the first method to get it in terms of y and then stick it into this section here. But in this case, minus 2x plus 3 is the second equation. There it is. Right? Now, of course, that doesn't tell you what the point is. So you go into menu, analyze graph, and look for intersection. And then it asks you to nominate a region. Click on the left, click on the right, and it gives you the same answer, but this time in terms of a coordinate. Now, the upside of this method is that you can see what's happening. Yeah? That's about it. The downside of the method is you got to get everything in terms of y. What was your question, Daniel?
Are we going to be needed to do something like this with graphs?
Yes.
in the test?
Yes.
So it's worth testing.
Yes. And then, Klein? Okay.
Mr. Rumlingham, there's a third method.
And let me just shut this thing down.
Could you very quickly just...
Hang on.
Which question are you looking at in 3i?
So I'm confused with the
first one.
graphs.
Yeah.
When we actually, so in the SAC,
3i, 2
one question that's a simultaneous equation.
Yeah.
We specifically asked us to put into graph form. But then how do you even know that we put into a graph?
Because I just showed you.
But how do you know that?